and welcome back to the channel. So today in this video lecture we'll be learning about Trie's data structures. So this is the very first video of the series. In this video we'll be learning about the basics of Tries, why we use Tries, and what are the functionalities which are supported by this data structure. So tries are data structures which are used to store words, and we can also search for a particular word in the try. We can also check if a particular word starts with a particular prefix which we are searching for. We can also count the frequency of any word using try data structure. So this data structure supports these functionalities optimally. Okay, we can perform these operations in an efficient manner using these data structures. So let's build the tries over these bunch of words. So we have these words, we want to build the corresponding try for these words. So let's start with the very first word, try, T-R-Y. So first of all, we use a root node. So this root node basically directs us to the very first character of the words. Like here, while inserting the very first word try, we start from root and we check if we have a pointer which points to T. We can see that we do not have any such node. So we create a node corresponding to T, which is the very first character, and we point from root to this character T. So we have a child node from the root which is character T. Now from T, the second character is R. We want to find a path from T, from this root to this Y, okay, which contain all of these characters. That means R must be a child of character T. Is there a child for character T which is R? No, we don't have. So we create a child R for the character T. Then we move to the third character. Is Y a child for character R? No. For node number R, we do not have a child which is Y. So we create a child T for this character R. We create a child Y for this character R. Now, this word is inserted because this Y is the last character of this word. So here at this node, we also have to mark that this is the ending character. So we keep another variable, let's call it is and variable, is and we mark this is and variable for this node to be true because this represents the end of the particular word. Okay, so this boolean variable is maintained for every node of the try just to mark if that particular character represents the end of the word which is followed along the path. So here this character Y is followed along the path TRY, and this is the last character of this word. So that's why we mark this variable to be true. So let's just try to insert the second character. So let's say we have marked this to be true. Now let's move to the next word, that is car, C-A-R. So we start from the root and we check if we have a child which is C. No, we don't have such child which contains C. So we create a child node and we push this character C into the child node, and let's move to the next character which is A. So do we have a child for character C, for node containing C which contains A? No. So we create this child node A. Now we move to the third character which is R. Do we have a child which is R for character A? No, we don't have. So we create this character. So we create this node which contains this R. And now this is the last character of this word. So we mark it as the ending word. So this is the ending character. Now let's move to the next word which is cat. So do we have a child node for this root node which contains this C? Yes, we have this. Now we move from C to A. A is the second character of this word and we check if A is a child node for character C. Yes, we have A here. Now we move to the third character. Do we have T as a child node for character A? No, we don't have. So we create a node corresponding to character T and we mark it as the child node for character number A. And this is the last character of this word cat, so we mark it as the ending word. we mark its boolean variable is and to be true because this is the ending character of particular word cat. Now let's move to the next word, which is trie, T-R-I-E. Start from the root node, check if we have a child node which is T. Yes, we have T here. Now from T move to the second character, which is R. We also have R as the child node for character T. Do we have a child node for character I? No, we don't have. So we make a new node which contains this I and mark it as the child node for character R. We move to the fourth character, which is E. So we also create a corresponding node for character E and mark it as the child node for character I. Now we also mark this character as the ending word because this is the last character of this word try. So let's move to the next word, which is cards. Do we have a child node for this root node which contains C? Yes, we have this C as the child node for this for the root node. Now do we have a character A which is the child node for character C? Yes, we have A here. Do we have R? Yes, we have R. Do we have D as the child node for character R? No. So we create a node which is the child node for this. Okay. Okay, so we have this node which contains D, which is the child node for character R. Now, do we have S as a child node for D? No. So we create S as the child node for character D. And we mark this S to be is end because this is the ending character of this word cards. Okay. Because in this cards, S is the last character. Now, finally, we are done with inserting all of the words in the trie. And we have our trie prepared. Fine, so we have a trie which starts from the root node, and from that root node we have corresponding paths, and these paths constitutes the words which we have inserted. Like this constitutes trie, T-R-Y. This path constitutes trie, T-R-I-E. This path constitutes car, C-A-R. This path constitutes T, like cat. And finally, this path constitutes cards. Starting from this C-A-R-D-S. Fine. So in this fashion, we build our trie. What kind of functionalities does this trie support? So let's see that. Now, first of all, this was the insertion. We can also perform search operation in tries. We can search for a particular word in the given trie, whether it exists or not. Like for instance, let's say I want to search for cat. So how would I search for cat in this trie? I'll start from the root node and I will also keep a pointer for the very first character of this string cat, and I will check if we have C as the child node for root. Yes, we have C as the child node for root, for the root node. We move to C and we move to the second character of this string. We check if A is present as the child node for character C. Yes, A is present here. We can see that. So we move to this node containing A. Now we move to the node containing T. So let's see if T is a child node for character A. Yes, we have T as the child node for character A. So at this final character of this string, we have to check if it marks the end of the word. If the is and variable, the boolean variable which we have kept for every character or every node, is marked as true. If it is the case that means this is the ending character, and this is also the last character for this word, and that means this word exists in the trie. So we return true, otherwise we return false. So this is the procedure to search for a given word in the trie. We have already discussed how to insert a word in the trie while we were building our trie. So the next operation that this data structure supports is count frequency. Now, let's say we have this word car inserted 2 times into the trie. So what do we do in this case? We simply start from root node. We move to the C because like here we have C as the child node of this root. Now we move to the second character A and we ask, is A present as a child of node C? Yes, A is present here, so we move to A. Now we move to R and we check if R is a child node for A. Yes, R is a child node and it is also marked is end. That means R marks the ending of the word. Means CAR is already inserted in this trie. And but we want to count the frequency, that is how many times we have inserted a particular word. To do so, we simply keep a variable, integer variable count initialized to 0 for every character. Like here in this character we keep count, and whenever we mark the ending of a word at a particular character, we simply increment this count variable by 1. Like here, initially when I inserted car, when I reach this character R, I simply increment this count by 1. So R stored 1 initially, but when I inserted this character second time and I marked R as the ending character of this word, I simply increment this count to 2. That means this is the ending character and we have encountered this character twice. Means this word, the word where which ends at R, has appeared twice, and we return this frequency from this function. Fine. So that's all. That's how we count the frequency of a given word. Now the another functionality which this trie supports is starts with. So we want to check if there is a word which starts with a certain prefix. Let's say we want to check if there is a word which starts with say, which starts with CA. Let's see how we can check it. We simply starts from root and we see if C, which is the first character of this word, is a child node for this root. Yes, we see C is a child node for root. We move to C. Now we move to the second character of this prefix, which is A. We check if A is present as the child node of this C, of the node containing C. Yes, A is present as the child node. And this is the last character. Since we have found this prefix in this tree, that means this prefix do exists in this trie, and there are words which starts with CA, and hence we return true, otherwise we return false. Okay, so these are the functionalities, namely insert, search, count frequency, and starts with, which a trie supports. Although there are other problems which you can also solve using trie, which we will be discussing in the upcoming videos. So in this video, that's all I want to discuss. The technical details like the implementation and the time and space complexity, those things I will discuss in the next video. We will be learning about two different implementations of the trie data structure using pointers as well as using adjacency lists. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and stay tuned with me for further updates in the series, and I hope to see you all in my next video.